All right, so let's look at these questions. So the first question, Chadwick got the Nobel Prize on the discovery of dash, and Thomson discovered dash. So the first option, neutron and proton. So basically, Chadwick discovered neutron, right? But what did Thomson discover? Thomson in his cathode ray experiment, he discovered electron. So this is out. So this also is out. So it has to be neutron and electron. So this is out. So this is the right answer, neutron and electron. So the ratio of the magnitude of charge to electron was determined by dash. So J. Thomson in his cathode ray experiment, it determined the charge to mass ratio of electron. So the right answer is this. So Medicon only discovered the charge of an electron. Chadwick discovered neutron and mostly discovered number of proton. Let's calculate the binding energy for cobalt. Given that the mass of cobalt is this, when determined with mass spectrometer, so we have this to be the value. So this is basically the actual mass of the nucleus. So assume that the mass of hydrogen is this, and this. So basically, the formula for calculating binding energy is E equals to mc squared. So m is the same thing as the mass defect. So the mass defect is m. So c, this is the velocity in meter per seconds. So also calculate the binding energy, we need to calculate the mass defect. Mass defect is simply we have it to be mass of proton, times the number of proton. So the mass of proton is given here in AMU. So times the number of proton, number of proton. So you add this to the mass of neutron times the number of neutron. So we have this. So minus the actual mass of the nucleus. So in the question we have that cobalt, that's 59 and 27. So this is the atomic number, and the atomic number is the same thing as the proton. So the proton is 27. So the neutron, this U. So neutron is 59 minus 27. So we have this to be 32. So now for us to calculate the mass defect, we need to do this. So changing the mass defect equals to the mass of proton is this. We have it to be 1.008142 times the number of proton, which is 27. So we have this plus the mass of neutron, which is 32, times the number of neutron. Number of neutron is 1.008982. So everything minus the actual mass, which is 58.95182. So this becomes 27.21984 plus 32.287424. So when we add the two together, we have 59.507258. So also so when we remove this from it, 58.95182, we have everything to be 0.555438. So this is the value of the mass defect, but in AMU. So we need to convert this to kilogram before we can use it in this equation here. So therefore we have this multiplied with 1.6606 times 10 raised to power minus 27 kilogram. per AMU. So this AMU cancels out, and we have the value of the mass to be 9.2236 times 10 raised power minus 28 kilogram. So basically, the value of the binding energy therefore is 9.2236 times 10 raised power minus 28 times the value of velocity. The value of velocity is 3 times 10 raised power 8 meter per second. So we have this to be 3 times 10 raised power 8 meter per second. So we are scaling this. So the final answer therefore is 8.3 times 10 raised power minus 11 joule. So this is the answer. Try it and ensure you get this. Let's look at this question. Given that the mass to charge ratio of an electron to be this, so we have that the mass to charge ratio. Remember that we only derive charge to mass ratio. So if the mass to charge ratio of an electron is given to be this value, so calculate the radius of the circular path by an electron moving with the speed of this and with magnetic field strength of 400 Tesla. So we have that E charge to mass ratio will be equals to E over B square R. So but we're given this, so therefore we have that M E to be equals to B square R over E. So we have this to be 5.69 times 10 raised power minus 10 kilogram per coulomb. So we have that the speed, which is the velocity, is 5.60 times 10 raised power minus 11 meter per second. We also have that B, the magnetic field strength, will be 400 Teslas. So the next thing we need to write is to write the equation that we have. So we have this to be so the force on the electric field is this. So we also have that centripetal force to be this, right? So we've got these values. So but looking at these two, we have that BEV equals to E and E. So when you cut this out, so we're left with this and this. So remember that we have the value for B. So this is 400 times the velocity. So the velocity is 5.60 times 10 raised power minus 11. So it will be equals to E. So we don't have the value of E yet, so let's get E. So E becomes 2.24 times 10 raised power minus 8 coulomb, right? So now putting this into this equation here, so we therefore have that our B is 400. So we have B to be 400. So put it to be square times the radius. We do not have the radius yet, over. So we have that the field strength is 2.24 times 10 raised power minus 8. So we have the O ratio to be this. So this is what we have, 5.69 times 10 raised power minus 10. So our radius should be what? Our radius should be approximately 8.0 times 10 raised power minus 23 meter. So it's the same as this when you approximate this. So this is the answer. Alright, so let's look at this question. So copper has two naturally occurring isotopes. So it has this mass and this abundance. So what is the atomic mass of the second isotope? So basically, relative atomic mass RAM is equals to the summation of the mass times abundance of each of the isotope over summation of the abundance, which should be 100%. So basically we have that RNA, we're given that the relative atomic mass to be 63.546. So RAM equals to 63.546. So therefore we have that 63.546 equals to so for the first isotope, this is the mass and this is the abundance. So we have it to be 62.9296 times 69.15. So plus the second isotope was not given the mass for the second isotope. So let's put it as M2. So for the abundance, it's simply 100 minus 69.15. So 100 minus 69.15 is 30.85. So this is the abundance of the second isotope. Remember that the total mass, the total abundance should be 100%. So 100 minus this should give us this. So over 100%, right? So we have that this becomes 6354.6 to be equals to. So when we do this, we have it to be 4351.58 plus this becomes 30.85 M2. So therefore we can see that M2 equals to 2003.02 over 30.85. So we have this to be what? 64.9277. So option D is the answer. Let's look at this question. The sample of naturally occurring silicon consists of 3 isotopes. So let's say the isotopes are 28, we have Si, we have 29 silicon, and we have 30 silicon. So if the abundances of this is 4.70%, so let's say the abundance of this, since they are not given, to be X and this to be Y, and let's call our Y to be 100 minus 4.70 minus X. The total of it has to be 100%. So we have this to be Y, the value of Y. So we're given that the relative atomic mass of silicon is this. So we have RAM to be 28.08. So relative atomic mass equals to the summation of mass times abundance. So we have over the summation of abundance, which is 100%. So basically we have that 28.08 equals to 28 times X plus 29 times 4.70 plus 30, the bracket of 100 minus 4.70 minus X. So that is a 30. So mass, which is 28 times its abundance, 29 times its abundance, and this times its abundance. So everything all over 100. So we have this to be 2808 when you multiply this 100 by this. So we have this to be 28x. We have this to be 136.3 plus 3000 minus 30x minus 141. So therefore we have that we have 2808 minus 3000 minus 136.3 plus 141 equals to negative 2x. So therefore we can say that x equals to 93.65%. And so when we have our x to be 93.65, we can therefore say that y equals to 100 minus 4.70 minus 93.65. So we have this to be 1.65%. So we have this and this. So basically, this is the final answer. All right, so let's look at this question. So we have that in an experiment to determine the charge to mass ratio of the electron. So the experiment was performed twice using the same cathode ray. So by what factor must the magnetic field strength be changed in the second experiment if the electric field strength was reduced to a quarter of its initial value? So looking at this question, we were given that charge to mass ratio. So we have charge to mass ratio to be equals to E over B square R. So in this experiment, we're given that our magnetic field strength B1 to be B, so B2 to be unknown. So let's say that our E1 also is E, and our E2 will say that it was reduced to 1/4 of its initial value. So we have this to be over 4. So since we used the same cathode ray tube in this experiment, so it is safe to say that charge to mass ratio is constant and radius r is also constant. So therefore we have that E1 over B1 r square r equals to E2 over B2 square r. So therefore we have that E over B. So we have B square. So this cancels out initially, so we are not using it again. So we have this to be so we have E over 4 and B2 to be what? So we do not know the value of B2, right? So B2 square. So therefore this one cancels out this B. So we have that 4B2 square equals to B square. So when we divide both sides by 4, so take the roots of both sides, we have that B root of this and B square over 4. So take the root. So therefore we have that B2 equals to B over 2. So the initial magnetic field strength is reduced by half. So this is the final answer. So we have this to be this.